Welcome to this web lecture about interaction devices. Chances are that in the near future you will not actually be designing new devices, but it's good to learn from the real world and from history what exists and is used today to already imagine what will be coming in the future. So we have to first of all look at the human side. What can people do and what can they not do? We, for instance, see that the first thing that babies have to learn in interaction is hand-eye coordination. When you move your hand, your eyes actually see what is happening, right? And that way you can easily learn to point at something on the screen. Toddlers can handle this quite easily and have problems with indirect control, where they have to use a mouse while looking at the screen instead of at their hand. It's hard to do something with your hands without actually looking at your hands. In the devices, we see some evolution in both size and mobility. Devices become smaller. Take, for instance, a clock. That used to be a big thing that hangs on the wall, and now it is a wristwatch, and maybe in the future it will disappear as a device altogether. The same with mobility. Phones, for instance, are no longer fixed to the wall or standing on a desktop, but we first had quite large and now smaller and smaller portable devices, and in the end, most people now only use an earpiece or a so-called smartwatch, and the phone itself is already disappearing. So maybe in the future we won't be wearing anything at all anymore to call people. We don't know yet, but future will tell. There are 4 main types of devices, and we will have separate web lectures about each of them. For entering data, we mostly use some form of keyboard for text processing, for entering data in spreadsheets, and in the design of keyboards, speed and error rates are important factors that determine the design. Then we have to select items and point at things on the screen, for which positioning and precision in the movements are important, and new pointing devices are moving towards a direct interaction that allows you to point very precisely at where you want to be. Displays, right, are the main way in which computers can tell us things, and important aspects are resolution, how much can be shown on the screen, but also size. Right? On a large screen, you can show more stuff than on a small screen. And there's issues of the colors that a screen can show. But finally, there is also speech and audio. For some types of interaction, keyboards, pointing devices and displays are not suitable, and then we can actually make use of sounds and of speech input and output. Let's briefly look at each of them. Keyboards. We all know keyboards like this, although in a somewhat modern form. Right? The typical QWERTY keyboard that goes back about 100 years in the earliest typewriters that used hammers, as you can see in this image. Problems that existed with these hammers were, for instance, jamming, and the keyboard design was created to avoid errors, so it was error prevention, but the type of error here would be the jamming of the keys, of the hammers actually. So we now use QWERTY keyboards. Well, we don't have hammers anymore. We should learn, right, to optimize keyboards for the new devices we have. In pointing devices, we see a move towards direct control. On touchscreens, simple hand-eye coordination is enough to point at the elements we want to select. This is fast, accurate, and toddlers can already learn it. Historically, we are more used to indirect control, for instance, using a mouse or trackball, where our hand is making a movement that we first of all don't see, and that, for instance, in the case of a joystick, may not be corresponding to what is happening on the screen. Indirect control is hard to learn, but it can sometimes be funny, right, to watch toddlers struggle with a mouse, but also elderly people who are not used to computers have such problems. Displays are the primary forum for receiving feedback and output from a computer, and there are many aspects that we will consider when choosing the right type of display. The physical dimensions, large screens can show a lot of information, but also resolution. Higher resolution means that the output will simply look nicer. The number of colors that a display can show will influence how we will deal with color in designing the output. Photo manipulation, for instance, requires that you know which colors the display can show. There's aspects of luminance, contrast, and glare, especially important when we're using displays outside. But one of the important aspects in choosing the right mobile phone is whether the screen is readable when you are outside, on the beach, in bright sunlight. Right? Most people then will only think about the phone being waterproof when you might encounter a wave and the phone gets wet, but the visibility of the data on the screen is most important. And then there is power consumption, the best possible image on the screen, and fast response rates for games and videos may actually draw too much power, right, resulting in shorter battery life. All of this can be solved, but it comes at a cost. And we have to consider that people buying a device have a limited budget, so the whole design becomes a compromise. When all of these interaction types are not possible, for instance, when we actually have to look elsewhere, or we are operating a machine with our hands and cannot use a keyboard, then speech and audio become good ways to interact with the computer. Speech and audio is also used for people who are physically challenged, people who cannot read a screen or cannot operate their hands sufficiently well, right, to type on a keyboard or control a mouse. It's also a matter of getting the computer to do the right things. There are easy applications like answering machines. They store and they replay speech, but they don't have to actually recognize the speech, let alone understand the language. The more interesting applications require computers to understand what we are saying in order to perform tasks, and perhaps they also generate speech to talk back to us. Thank you for participating.